In this video, we'll learn about types of electrolytes. Electrolytes are of two types. The first one we have strong electrolyte and the second is obviously weak electrolyte. So strong electrolytes are simple. They completely split off into ions in their aqueous solution. The aqueous solution or melt of these electrolytes allows a large amount of current to flow them, that is they have high electrical conductivity. So suppose we have an electrolyte which is HCl. Initially, I have taken 100 molecules of HCl, and as I dissolve it into water, it will completely get dissociated into H positive and Cl negative. So all the 100 molecules will be dissociated into H positive and Cl negative ion. So they will completely split off. So obviously, as high splitting or maximum number of molecules will get dissociated, the conductance will be high due to more free mobile ions. So they have more, or you can say only free mobile ions. The solution of these electrolytes contain only free mobile ions. Example, we have strong acids like HCl, HNO3, H2SO4, strong bases NaOH, KOH, etc. Another example is we have salt of strong acid and strong base, strong acid and weak base, strong base and weak acid. They all are strong electrolytes. Here you can read sodium sulfate, sodium chloride, ammonium sulfate, sodium acetate, potassium methanoate, etc. Now let's talk about weak electrolyte. So as we talk about HCl, but for weak electrolyte, let's suppose an example, this CH3COH. On dissolving it in water, let's take its 100 molecules. But as I will dissolve it into water, it is not going to be completely dissociated into water. From 100 molecules, around, let us suppose 50 molecules will get dissociated into CH3CO negative and H positive. 50 will remain undissociated. So they only partially split off. Here you are able to see that they partially split off into ions in their aqueous solution or melt. So as the number of ions are low, obviously small amount of electricity is going to be passed through them as compared to that of strong electrolytes. So the solution of these electrolytes contains ion as well as molecule. Here we have 50 ions of acetate ion, 50 H plus ion, and 50 molecules of acetic acid as well. So here, along with the ions, we will also see some of the molecules which are in their undissociated form. Example, we have acetic acid, carbonic acid, ammonium hydroxide, then salt of weak acid and weak base like ammonium acetate, ammonium carbonate, etc. Non-electrolytes such as glucose, ethanol, benzene, CCl4 contain only even molecules in solution. So these are the electrolytes which even don't get dissociated into water. So if I'll dissociate or I'll put glucose into water, it will remain as it is. No ion is being found from glucose. So only molecules even in solution for such molecules that are non-electrolytes. Now let us perform an experiment to distinguish between strong electrolyte, weak electrolyte and non-electrolyte. What we need to do is we need to take a glass beaker. As you are able to see, this is a glass beaker and we have two graphite electrodes in it sufficiently apart in the beaker. Now let's just connect the two electrodes of the terminal from the battery B and we have a switch A. Now let's place an incandescent bulb B in the circuit as shown in the figure. Just put the aqueous solution of the given substance. Firstly, suppose you will put a solution A, then you will put another solution B, then you will put another solution C, and then study by switching on the current. Now what you are going to do, what you are going to observe is if the bulb glows brightly, what does it mean? It obviously means the amount of current is obviously high. Power generated or power generated is also high. Hence, as the current is high, as the magnitude of current is large, the bulb glows brightly. That means it is going to be a strong electrolyte. But if the bulb glows dimly, then what is going to be the observation? It is simple that it must contain weak electrolyte because the amount of current is low, because the power generated is also low. Then finally, if the bulb doesn't glow at all, that means there is no as such solution which is conducting the electricity. No ion is present in the solution. Hence, this is going to be the non-electrolyte. I hope it is clear to you. Thank you.